Rational numbers. Before getting into rational number, can you tell me about like number system, what all the things you know about integers, whole numbers, and natural numbers?
Yes.
Can you tell me about the integer?
Integers are like represented by a number line. The
Yes.
numbers on the left of the zero are called negative numbers, and the ones on the right are called the positive numbers or just numbers.
Not exactly like that. Integers are, let me clear the basics first. Integers like a counting numbers. Can you tell me the some way you'll start the numbers?
Sorry?
Uh, Before getting into the integers, wait. Let's start with the natural numbers first. One second.
1 second.
कोई बैठ के खड़े मत हो जाए उसको बोला था ना रिमूव योर सॉक्स
Can you give the idea of natural numbers for me?
Natural numbers, like
Yes,
from all the numbers from 1 to infinity.
yes. We'll start counting from 1, 2, 3, 4, and so on. These are all the natural numbers we know. May I know about the whole numbers?
Whole numbers are like the numbers including like from 1 to infinity, 0, and also -1 to infinity.
No. Whole numbers will not include negative numbers. Whole number is it is all in natural numbers 1, 2, 3, 4. But we are including 0 in the whole number. Get it?
Mm-hmm.
Okay. Next part is integers. In the numbers system, we are having in the beginning natural numbers, next whole numbers, then integers. Can you tell me about integers, whatever the things you know about it?
Okay, integers, we basically learn about the number line first. So including 0, the all the negative numbers on the left, and then all the positive numbers on the right. And about minus infinity and plus infinity, and also the calculations like minus and minus give always plus, and plus always give plus, like the other things.
Exactly. This is the number line, and in between what we are having, definitely 0. And the right side of this number line, what all the numbers we are having, all of them are positive, right?
Hmm.
It will be up to infinity. And in the left side, we are having the negative numbers -1, -2, -3, -4, and it will go on. The
Hmm.
numbers which are in the right part, they are called as positive integers. Yes, clear?
Yeah.
Yeah. All the numbers in a number line which are there in the left side, they are known as negative integers. Clear?
Hmm.
This is all about natural number, in whole numbers and integers. Do you have any idea about fractions?
Yes.
Okay. Before getting into the
What?
rational numbers, we need to know about the fractions. Can you tell me about the fractional numbers?
A fraction is a part of a whole. For example, a quarter,
Yes.
half, like 1/2, 1/4.
Exactly. When we have a whole part, if it is a circle, this is equals to 1, right? If I make a half of it, like I'm making half of it, then how many parts I'm having here?
2, 1/2.
Two parts. How I'll write these parts? I'll write this as 1
1
by
upon
2, and this as
1 by
this.
2. 1/2.
This is a half of that one. We'll take a part of a whole thing. That is known as fractions. Yes.
Mm-hmm.
If you know about the fractions, knowing the rationals is the really easiest thing. Shall we move to the next? Shall we move to the next part? Is this
Yeah.
clear for you?
Mm.
Okay, ma'am. 1 second. Okay. Next, rational numbers. In this class, we'll know about the rational numbers introduction we got to know now, and I'll tell you the definition. Then we'll get to know about the properties of addition in the rationals. Okay, fine.
Mm-hmm.
You're clear with the introduction part?
Yes,
Do I have to slow down? Is it okay?
it's okay.
Okay. Definition of a rational number. Before getting into the definition, I'll give you a few examples. After watching these numbers, what you'll say for me? What are these numbers? 2 by 6, 1 by 8. What can you
Fraction,
say about these numbers?
fractions.
Yes, these are the fractions, right? Same as it is. I'll give the definition of rational. You will tell me the rational part, okay?
Mm-hmm.
Let me write the definition first. The numbers, give me a second, which can be written in the form of P by Q is known as rational numbers. In this, P and Q are belongs to integers. You got to know about the integers clearly, right?
Mm-hmm.
Yes. Here P and Q are belongs to integers and Q should never be equals to 0. Fine.
Okay.
Let me give you the few examples for that. In place of, as I showed you here, P by Q. Can you see this? In place of that, we can write it as 2 by 3. In place of P, I'm having 2. In place of Q, I'm having 3. Do 3 and 2 are belongs to integers? Are they integer numbers?
No.
Hey, why not?
Ah, numbers.
Actually,
Yes.
yes.
I thought like the whole thing.
No, ma.
That's a
They are
fraction.
belongs to integers.
Mm-hmm.
If I write them in the form of P by Q, as I showed you here, I showed you, right? P by Q.
Mm-hmm.
I had written the 2 by 3 in that form.
Yes.
Yes, these kind of numbers are called as rational numbers. Fine.
Okay.
Clear with the definition?
Yes.
Okay. Let's
Okay.
move. If this is okay, fine, or else we'll move to the next part.
Okay.
Any doubt?
No.
Okay, can you give me a few examples for rational numbers?
Like 1/4 maybe.
Okay, 1/4, then
3/4.
3/4 is also. Okay. Then
2/3.
1/3. Very good. These are the example of rational numbers. I'll give you a few examples. Like try to follow. Minus 2 by 3 and 1. Do you think these two numbers are rational numbers?
Um. Yes.
Yes.
Not one.
Not
Not
1.
one.
Why? Okay.
Because one is not written in the form of PQ.
Okay. Next, this negative is fine for you.
Yes,
Minus 3 by
because
2.
minus 2. Yes, because minus 2 is also considered as a integer.
Very good. And 3 is also integer. Let's come back to the definition. Here they told us q should not be equals to 0. Here, q is equals to what?
0.
3 is equals to 1. If I don't write anything, that doesn't mean that q is equals to 0. That means q is equals to 1 here. If I'm not writing any number in the denominator, that means 1 is there.
Oh, yeah, right. I,
Fine?
we, mhm.
You're clear with that? So, from this, what can I say? All the integers are what?
All the integers.
As I told you, if I write numbers like this 1, 8, minus 3, like all these numbers are integers,
Integers.
right?
Yeah.
Okay, I had given you one example here and I told you that here q is equals to 1. That means these integers are also equal to,
Rational numbers.
yes, very good. These integers are also rational numbers. Clear?
Mm-hmm.
Okay, ma. Next. Shall we move to the next or you need any conclusion part in this?
Yeah, I had one question.
Yes,
If rational numbers can be written in the form of like PQ, then what
yeah.
will be the difference between a fraction and a rational number?
In fraction, the numbers, the writing numbers, like if I'm right, one second.
Like
If
because
I'm,
sometimes in multiplication we also use like if it's only 100, then we put a line and then we write 1. So that's also a rational number. Then it turns
yes.
into a fraction. But then the
Hmm.
thing is, if 2 by 3, it can be
Hmm.
both, right? Rational number and a fraction. So which one is
Yes.
actually correct?
These rationals are fractions, ma'am. These numbers are fractions. Here in the rational number, I'm using operations on them, like addition. In fractions, only these numbers called as fractional numbers. But in the rationals, I'm giving the operations on them. If I'm having 2 by 3, also if I'm having 1 by 3, you say that this is the rational, this is the rational. Sorry, you say that this is a fraction and this is also fraction. Yes,
Mm-hmm. But it can
uh,
also be a rational. But then what
it
is the
is
difference?
rational. If I take only one of these, it will be a fraction. If I'm using any kind of operation like addition, subtraction, multiplication, division, and I can form a numbers after that also. Like denominator is same, I'll take it same, and I can add the numerators. So this will be 3 by 3. When I'm using, we made rational to use the operations on fractions. Clear?
Okay.
Fractions is only one number. If you are having 1 by 2, this is the only fractional number. If you are having 3 by 6, this is the only fractional number. But in between 1 and 2, in the number line, in between 1 and 2, there are infinite number of fractions are there. They together called as rationals. Clear?
Mm-hmm.
If you are clear, we'll move to the next or else we'll discuss.
No, it's all right. I understood.
Okay. Next part is properties of addition. There are few properties and addition. Do you know any of them?
Properties of?
Addition.
Mm, I don't know like the properties, but I know how to do it.
One
Like
second.
the denominator should be the same,
Mm,
and when the denominator changes, the numerator changes in the same value. For example, if I
mm,
want to add 1 by 2
mm,
and one fourth. So I will have to make the denominator same as the
Yes.
second. So for
Yes.
example, 2 into 2, and then I'll also have to do 1 into 2 for the numerator.
Yeah, exactly. There are few property. If I tell the names, you will definitely know about them. Like closure property, committed. You know commutative property.
No, I didn't hear about that one.
Okay, commutative property, then associative property, additive identity, and additive inverse. These are the properties we are having in addition. Let us know one by one. Okay. First one is closure property. Let me explain you. When we add two rational numbers, we always get another rational number. I'll tell you this. If I'm having rational numbers like 1 by 2, is it a rational number?
Yes.
Next, one more. Like 2 by 2, I'll take it as 2 by 2. Why? Because we need the denominator same. Here, if I add them, can I add two rationals?
Can I what?
Can I
Yes.
add two rationals? Yes,
Yes.
we can add two rationals. In this case, denominator is same. So can I write 2 directly in the denominator?
Yes.
Okay. In the numerator part, this is 1 plus 2. Can I add the numerator?
Yes.
This will be equals to 3 by 2. Is it a rational number? Whatever the answer I had got,
Yes.
I had two rational numbers. Yes.
Mm-hmm.
I added them. What I got in the answer?
3 upon 2.
Ah, what is that?
That is also a rational number or the
Yes.
answer.
That's what the closure property says. When we add two rational numbers, we always get another rational number as the answer. Fine?
Mm-hmm.
So, rational numbers are closed under addition. Is this property clear for you?
Yes.
Okay. Shall we move to the next property, that is commutative property? This is the one more property of addition, that is commutative property. Okay. Changing the order does not change the answer. Like if I write 2 plus 3 is equals to 3 plus 2. If I add 2 plus 3, what I'll get?
5.
5. If I change the order, I take 3 first and 2 next. If I add 3 plus 2, what I'll get?
5.
5 again. This is what our uh, commutative property try to say us. Okay. We'll use the same strategy in rationals. Can you tell me two rational numbers?
Um, 5 and 4.
Okay. Let's not take in that form. We'll take in the form of P by Q.
Oh, 5 upon 6.
Okay. Then one more.
Um,
Keep the
7.
denominator same.
The same. Then 4 by 6.
One second. 4 by 6. Okay. If I change the order, what I'll get in next?
Like the same answer. 9 upon 6.
Yes, that is 4 by 6 will come in the beginning. Same that 5 by 6 will come next. Denominator is same. I'll take it as same. This is 5 plus 4 and this is equals to 4 plus 5. So the answer will be 9 upon 6 is equals to 9 upon 6. Clear?
Yes.
Is this property clear for you?
Mm-hmm.
Okay. If the speed is fine, I'll continue or else I'll slow down.
No, it's fine.
Okay. We'll move to the next property, that is associative property. What is our next property?
Associative.
In this property, same thing we are going to apply as we got before, but we are grouping the numbers here. Like 2 plus 3 plus 6 is equals to, same, I'll take the same order, 2 plus 3 plus 6. I'll just group them. Like a 2 and 3, I'll group first. Then here, I'll just group 3 and 6 next. Try to add them. 2 plus 3 is equals to
5.
5. This plus is there and 6 is also there. Next, we are having 2 here, plus 3 plus 6 is equals to,
8.
no, 9.
3. Okay.
Uh, okay. Add 5 and 6,
11.
11. Add 2 and 9.
11.
Okay. Our associative property is saying that if I group the number, grouping doesn't change the result. If I here 2 by 3 is having a group, here 3 by 3 and 6 are having the group. So does it affect the answer?
No.
Same thing will apply in our rational number. Can you give me two examples? Keep it in a P by Q form.
Mm-hmm. In a P by Q form,
Yes,
like 1 by 2
1 by 2
plus bracket
plus,
7 by 10 plus.
no, keep the denominator same because it will be
Oh,
helpful for adding.
okay, but then we'll have to raise 7, right? Or
Yes,
is unlike fractions okay?
no, take the like fractions first.
Okay,
We'll do for unlike fraction in our further classes.
okay.
Let's keep it simple. I'll take it to next.
And 3 by 2.
3 by 2. Fine. Same order I'm going to take 1 by 2 plus 7 by 2 plus 3 by 2. I'll group 1 by 2 and 7 by 2. Fine. Okay. If I add them, 1 by 2 will be as it is there. This 7 by 2 and plus 3 by 2 will be
10 by 2.
10 by 2. Very good. Equals to 1 by 2 plus 7 by 2 is equals to
8 by 2.
8 by 2 plus 3 by 2. If I add them, 10 plus 1 will be 11 and this is 2. And 8 plus 3 will be
11.
11 again and it is 2. So this is what associative properties try to say us. If I group the numbers, the answer doesn't affect it. Correct?
Mm-hmm.
Clear?
Yes.
Okay. If it is clear, I'll move to the next that is additive identity. Identity means while adding, if I'm adding any number to the number, whichever I am having, I have to get the same answer. Okay. If you are having any number, okay, tell me one number. Any
7.
number. 7. Okay. You have to, this is additive identity, so I have to add. Okay. You have to add any number for 7. And in answer, you have to get same number. You have to get 7 again. What you will add?
0.
Exactly. Very good. You're smart enough. This is our additive identity. Okay. If I have a, rational number like 2 by 3, I have to add one number for it and I have to get 2 by 3 as the answer. What the number should be?
0.
0 again. So what you got to know about this? What is our additive identity of rational number?
If a number is
No,
added to
identity.
0, what?